Hello everyone, this video is going to cover lesson 6.5, which is the introduction to binomial random variables. This is a very important lesson. I wish I was in person to teach it to you, so I am going to really take the time to walk through all of these parts of this lesson. What you need is a calculator, and your formula sheet would be handy too, because we're going to be learning a new formula today that is on your sheet. The U.S. women's soccer team is doing some calculations to help prepare for the upcoming World Cup. They are convinced that the toughest matches are likely to end in a tie. These matches require a shootout to break the tie, where each team gets 5 penalty kicks. They believe that they need to make 4 or more penalty kicks to win. Over the history of the World Cup, about 70% of penalty kicks in a shootout are made. Let's assume this is the probability for each of the players on the U.S. team and that each kick is independent. What is the probability that the team will make all 5 penalty kicks? So making the first, making the second, and making the fourth and fifth. So that probability is given to us right here, 70%, whereas a decimal, that is 0.7. So since each trial is independent and each player has the same probability, then we are multiplying 0.7 5 times, or we could shorten this to 0.7 to the 5th. And if you do that calculation in your calculator, then that would be about 0.168. What is the probability that the team will make exactly 4 of the penalty kicks? So one way that this could happen is making the first 4 kicks and then missing the last one. So let's expand that out. That would be 0.7, so making the first, making the second, making the third, making the fourth, but missing the fifth. So if making is 0.7, then missing has to be 0.3, because you're either making it or missing it. So we could write that using our exponents, kind of similar to what we did up here. That's going to be 0.7. We have 4 of these, and then 0.3 makes up 1 of these. Now, if you type that into your calculator, you're going to get 0.072. So that is the probability of making the first 4 and then missing the last one. Name another way to make exactly 4 penalty kicks and then find the probability. So what I mean is that in this scenario that for 2A, we missed the last one, but we could miss the second to last one. We could even miss the third to last one. So let's actually write out the words. We're going to miss the 4th kick. So make, miss, and make. So if we were to, in order, so this is our first kick, we make that one, we make the second one, we make the third one, but we miss the 4th one, and we make the last one, the 5th kick. So if we were to use our shortened notation, we'll see that we have 4 0.7s again, and only 1 of the 0.3s. Okay, so that's just a different way of writing, using exponents, this probability. And if we were to calculate it, we can see actually that when we use the exponents, it's the same probability that we calculated above, and we get 0.072. So what do we notice? They're the same. So they both equal 0.072. How many different ways are there of making exactly 4 penalty kicks? So let's list them out. We have already talked about 2 of them, and I'm going to use check marks and X's so that way we can fit it all in here. So we could have 4 makes and a miss. We could have 4 makes and a miss, but the miss is on the 4th shot. The miss for the next one could be on the 3rd shot, or the 2nd shot. 1, 2, 3, 4, 5. Yep. And then, or we could have the 1st shot is a miss, but then the 2nd, 3rd, and 4th are a make. So there are 5 ways to do this. And again, this is just of making exactly 4 penalty kicks, because remember, we're interested in 4 or more. So 4 or more. So we listed out the 4. We actually already calculated for making all 5, because all 5 would work also. Overall, what is the probability that the team will score on exactly 4 of the penalty kicks? Show your work. So we already showed our work for 2 of them, or like actually calculated it out, the 5th miss and the 4th miss. But we can see that even if we have the miss, the 3rd spot, or the 2nd spot, or the 1st spot, all of these probabilities are going to be the same. They're all going to be 0.072. So what is the probability that the team will score on exactly 4 of the penalty kicks? Well, we take those 5 probabilities and we're going to add them together. Because again, there are 5 ways of doing this. So we're going to take 0.072 and add them together. So we get a probability. If we add those 5 numbers together, those 5 probabilities, the probability that we get exactly 4 of the penalty kicks is 0.36. One student calculated the probability of making exactly 4 of the penalty kicks using this formula. Identify what each part of the formula represents. So we have seen this formula, at least this portion of it here. Okay, so this part right here, this 0.7, that I'm going to go back to the 5, but the 0.7 represents the probability of making the shot. And the 0.3 represents the probability of missing. Okay. The 4 represents, well, let's look at where we see 4. We see 4 here. We see 4 here. So what that is, and here, so what that is the number of makes. And that means that out of the 5 shots, the 1, since we make 4 of them, this is going to be the number of misses. The 5 at the very beginning, that's the only thing that we don't have labeled. The 5 is the number of ways that this can occur. Now, for us, for this example, this is where in part D. So that was the 5 total ways. We were able to list these out. So you can imagine that if our numbers are larger, let's say that there were 20, let's say there were 20 kicks, for example, and we wanted to find 13 or more, whatever. That would be very, not difficult, but tedious and time-consuming to list out. So we don't always want to do that. So we're going to talk about how we can, there's a formula basically that will help us do that. So let's actually, before we do that, let's answer number 4. So if a World Cup game ends in a shootout, what is the probability that the U.S. team wins? So that is, well, we've calculated these various probabilities. In order to win, we need 4 or more. So the 0.36 is our probability that the team will score exactly 4. And then we calculated the probability of making 5 penalty kicks. So both of those scenarios would ensure that the U.S. team wins. So we're going to add those 2 probabilities together. So that was for 5. The 0.168 was for 5 makes. And then the 0.36 is for 4 makes. And so that probability, adding those together, is 0.528. All right, so I'm going to go back to, first I'm going to talk about in the quick notes, I'm going to go back and forth a little bit. So for binomial random variables, we have certain conditions that need to be met. And the one thing that I want you to remember is this acronym called BINS. So a lot of times you're going to be expected to check these conditions. And we'll talk about BINS. Actually, you'll see it pop up, kind of frequently for the rest of the school year. So X is going to be the number of successes. And the notation here, B, N, P. And I'll tell you what N and P mean in just a moment. So the first is B, stands for binary. So we have 2 options for a trial. It's either a success or a failure. In our example, it was make or miss the penalty shot. The trials must be independent. So that's what the I stands for. So the outcome of the previous trial, or in our case, the previous shot, does not impact the next shot. The number of trials has to be fixed. That was where your N comes in. So the number of trials. And then the last is the same probability of success. So for our probability of success in the example that we just did, that was 0.7. And then the number of trials was 5. 5 total shots. So let's go back up and just verify that this actually meets the binomial setting, because we didn't check these conditions. So binary. So it needs to be a success or a failure. So it either is made or it's not made. So we have that. Okay, so, and just by the nature of shooting a penalty kick, it's either made or not made. So the made is a success and not made is a failure. The number of trials is, let's go in order. So that's binary, independent. So oftentimes it's just going to say that it's independent. And here we have that here. So each trial is independent. We have that condition. N stands for number of trials is fixed. And that's met right here. So the number of trials is fixed. And then the last is the same probability of success. For each trial. So here we have verified that the conditions of the binomial setting actually are here. Let's actually go down, and I'm going to introduce the formula. We're going to start or go to 2D. And so we figured this out, that there were 5 ways to calculate this by hand. But again, if our numbers are larger, this is going to be difficult or tedious to write out. So we don't want to have to do that. So here is where we're going to use the calculator function. So the calculator function is under, and I'll show you here in just a second, it's under math and then probability. And what you'll select is N, and it's a capital C and R. So let's go to the calculator and do this with me, please, because you're definitely going to need to know this. So you're going to hit math, and then all the way over, so math, numbers, complex, probability. So on the 4th selection here for me. And then notice that we have NPR and NCR. We are not using NPR. We're using NCR. So you're going to select that. And most of your calculators, you're just going to have to use the arrow. So what you're going to type in is, hold on, let me go back here. So the N is, remember, the number of trials. So that's 5. And for whatever reason, they use R instead of K. So R is our K value. So you're going to type in 5, choose 4. Okay, so 4 is the number of penalty kicks that we want to make in this scenario here. So you're going to type in 5 and then arrow over to the next box and then type in 4. So it should look like that. If you have an older calculator, you're maybe it's not too much more difficult, but it's just going to look a little different. So anyway, let's hit enter, and it's going to give me the number of ways that I could get 4 successes out of 5 trials. So there's the 5. Okay, so again, you're going to want to utilize that today. If you have, let's go back to if you have an older calculator, then what you actually have to do is you have to hit the number 5 first, and then go to your probability, and then hit 4 afterwards. Like you have to like sandwich it in. If you're not sure, then just look up on YouTube how to do it. It should be pretty straightforward. Okay, so again, we got this 5 from using that feature in our calculator. So one thing that I want to define up here is that we should define our random variable. So this is right next to, underneath number 3. So X is equal to the number of penalty kicks made. Penalty kicks made. And that notation, probability of X equals 4. Okay, so all binomial settings are going to follow kind of this general format. So remember that using our new combination notation, or what we talked about up here, we're going to use the 5, choose 4, and then in this case it was 0.7 to the 4th, 0.3 to the 1st. So in short, what I'm trying to get at is that you can type this in as long as you know that it's 5, choose 4, and you know your probability of success, probability of failure, the number of successes, the number of failures. Then you can just type that into your calculator, and it is just going to give you this probability. So you type that in, and it's going to give you the 0.36 that we calculated earlier. Okay. Some other notation stuff here. So the probability that the U.S. team wins. So in order for us to win, that number of kicks has to be greater than or equal to 4. So you could just write that in next to your numbers here that you've already written down. Okay, so let's go back down to the formula. So the formula, we've actually already talked about this a little bit. So remember that this piece right here means the number of ways, and sometimes this is R, just so you know. K and R mean the same thing. Number of ways to get K successes. And now that I think about it, I can't remember if the TI-84, the true TI-84 uses K or R, but just remember that it's just a different letter to represent the same thing. So that is the number of ways to get K successes, that N choose K or N choose R. Remember that P, that is the probability of success. And what we do is we raise it to the number of successes. So P, again, is the probability of success. And K is the number of successes. Okay, so that again, for our previous example, that probability was 0.7. And then when we were calculating for 4 successes, that we raised it to the 4th power. Okay, so then how did we find that 0.3 value? Well, that 0.3 value, I didn't write that out, but what we did was we took 1 minus p, and that was where our 0.3 came from. And then how do you get the number of failures? Well, the number of failures, remember, let's go up here. The number of failures was 1 in our case. The number of successes was 4. And those two numbers add up to 5. So if you do 5 minus the total number of trials you have. So if you do 5 minus 4, that's how you get the 1. And so if you do n minus k, or 5 minus 4, that represents the number of failures. Now sometimes, or usually initially when I show this formula, it can be a little bit overwhelming. This formula is provided for you. But what's more important, it is not so much memorizing the formula, which you don't have to do, but understanding the pieces of the formula. So you actually might be able to come up with the whole calculation without really directly thinking about this formula. But the formula is there in case the formula, makes a lot of sense to you. Probability of failure. All right, so that's what all the pieces mean. Again, this means the number of ways you can get a success. This right here, the p to the k, represents the probability of success raised to the number of successes. And then the last part here represents our failure piece. So the probability of failure raised to the number of failures. Okay, I do want to go through the check your understanding with you. So, for each of the following situations, determine whether or not the random variable has a binomial distribution. Justify your answer. You play a game of whack-a-mole. From playing this game in the past, you know you have an 80% probability of whacking the mole before it drops back into its hole. The mole pops up randomly, and your ability to whack any particular mole is not affected by whether or not you whacked the previous mole. There are 20 moles to be whacked during one round of the game. Let X equal the number of moles you are able to whack in one round. So we're checking to see if we have a binomial setting. So that is where our acronym comes in. So binary, success or failure. Do we have a success or failure in this round, or in this problem? And we do, because we're either going to whack-a-mole or we are not going to whack-a-mole. So the binary condition is met. So each try is a success or a failure. Independent trials. So up here, they don't use the word independent, but they describe independence. It's not affected by the previous mole. So each try, and I use their wording, each try is not affected by the previous mole, so this is independent. The number of trials must be fixed. There are 20 moles. So n is equal to 20. We have a fixed number of trials. And then last, the same probability of success, 80% probability for each try. And so that is 0.8. So as long as these 4 conditions are met, which they are, then yes, we can say we have a binomial setting. So you do have to verify all 4 of these and then state your answer, which is yes, this is a binomial distribution. Next, you play skee ball. You know that you have a 10% probability of getting any given ball in the 100-point hole. Let y equal the number of balls you must roll until you get 1 in the 100-point hole. So if we go through and check our conditions, I'm just going to talk through them. Binary is we have a success and a failure. So the success is going to be that you get the ball in the 100-point hole, and the failure is going to be that you don't. Independent. We can assume independence here. Even though it doesn't explicitly say independent, we can assume that because each roll makes sense. Each roll is going to be independent each trial is going to be independent, meaning that the previous roll doesn't impact the next roll. The number of trials is fixed. That's the third condition, and that here is not met, and that is because you must let y be the number of balls you must roll until you get one in the 100-point hole. They have to say that there are 15 trials or any other number, but it is not fixed. That word until means that it is not fixed. So this is not binomial. Because the number of trials is not fixed. Okay. Now let's look at the number 2. Now you play a game called Tsunami Duck Pond, where there are 100 ducks that get pummeled by tidal waves. Among the 100 ducks, there are 20 with stars on the bottom, 30 with circles, and 50 with squares. You must reach your hand into the tsunami and randomly select a duck. If there is a star on the bottom of the duck, you win. After you select each duck, you must replace the duck back in the water. Let W be the number of times you win if you play this game 10 times. W is a binomial random variable, so there's no need to check the conditions here. They are telling you that it is a binomial random variable. Identify the fixed number of trials and the probability of success for each trial. So they tell us that we're playing the game 10 times, so N is 10. The probability of success, well, in order for us to be successful, we have to select one with a star. So stars, there are 20 of them. And then the rest, even though there are 3 categories of ducks here, the success is going to be the one with stars, and the failure is going to be if we selected a duck with circles or squares. So that those 2 are in that failure category for us. So to find the the probability of success, we're going to put the number of star ducks over the total. So 20 plus 30 plus 50 is 100. So you could write that as a fraction or a decimal, 0.2. Find the probability that you will win exactly 3 times, show your work. So here is where we're going to use the formula. And I will, again, walk you through how to do this. So let's write the correct notation. And another thing that you can do is you can find this formula on your formula sheet and just get familiar with where it's at. All right, so we want to win exactly 3 times. So we have, that is our K value, or maybe that's our R value. Remember that these 2 things, they mean the same thing. And the probability of success is that 0.2. So we already calculated that. So there are going to be numerous ways of getting 3 of these star ducks out of 10 trials. So we're going to say 10, choose 3. Let's actually make sure that we find that number. We're comfortable with finding that number first before we calculate anything else. So go to your calculator and make sure that you can get here. So math, probability, and oops, I hit the wrong thing. Math, and then mine is the third selection down, and I want 10, choose 3. Okay, so hit enter. And there are 120 ways of this happening. So think about it. That means that let's say that you got lucky the first 3 times and then unlucky the remaining 7 times. 1, 2, 3, 4, 5, 6, 7. Okay, so writing all of that out would be very difficult. So essentially, there are 120 of these iterations where we could have check marks in the various 10 spots. Okay, so let's finish writing out the using the formula. Probability of success is 0.2. How many times are we looking for that success? Well, it's this number right here. We want 3 successes. How many failures? Well, there's going to be 7 of them because 3 plus 7 is 10. But what goes in here for the probability of failure? Well, you're going to do 1 minus your probability of success. So that's going to be 0.8. Okay, so let's type that into the calculator and see what we get. So I'm just going to do the whole thing over again. 10, choose 3 times, oops. So times, and then I want to do 0.2 to the third times 0.8 to the seventh. So one line, enter, and we get 0.2013. I'll go to 4 decimal places. And just so that we understand what's going on, let's do the probability of, let's add one more problem here. So 4 wins. Okay. Oh, what am I doing? So let's fill this out. If I want 4 wins, I still have 10 trials, but I'm choosing 4. The probability of success has not changed, but the number of successes has. That's going to be to the 4th power. And the number of failures, if I have 4 successes out of 10 trials, and that means that I have 6 failures. Okay, so let's go back in, recalculate this. I think I can just delete some of these numbers, and I'm going to change them. This is going to be now 4. Delete 4. And then this is now 6. Okay, so 10 choose 4, 0.2 to the 4th, 0.8 to the 6th. So 0.088. 0.088. There you go. All right, email me if you have any questions. I know this video was pretty long. Sorry about that, but I just want to make sure that I got everything covered. And hopefully I should see you guys on Thursday. Bye.